Good morning and welcome to today's class. In today's class, we shall be looking at quadratic equation. Quadratic equation can be said to be an equation where the highest power of the variable is said to be 2. In today's class, we shall take the following objective: that at the end of the class, learners should be able to 1. Express quadratic equation as perfect squares. 2. Solve quadratic equation by method of completing the square. 3. We shall also deduce and apply the quadratic formula in solving quadratic equation problems. 4. We shall form quadratic equation using sum and product of given roots. And 5. We shall form quadratic equation from word problems. And 6. We shall solve the quadratic equation formed from the word problem. So these are the objective of this very particular topic. Let's look at factorization of perfect square. A perfect square is said to be a whole number whose square root is also a whole number. We have examples. 4 is said to be a perfect square because the square root of 4 is 2, which is equally a whole number and meets the definition. We also have 16 as a perfect square because the square root of 16 is 4, which is a whole number. We have so many of them: 9, 36, 49, 64. You can name a whole lot of them. Now, in terms of quadratic equation, how do we define a perfect square? Now, we said quadratic expressions of the form x squared plus 2xy plus y squared, or x squared minus 2xy plus y squared, are known as perfect squares since their factorization is either x plus y squared or x minus y all squared respectively. Now, that is, if you factorize this, you arrive at this, and if you factorize this, you arrive at this. And this, I'm going to show you how you can factorize to get each of the two square roots respectively. Now, we said a quadratic expression is a perfect square if and only if, please take note of this, if and only if, take note of these two conditions. 1, that the first term and last term are perfect squares. That is, the first term and the last term of the quadratic expression is a perfect square. Let's look at this, for example. This is the first term, this is the second term, and this is the third term. Now, the first rule or condition is that the first term and the last term must be a perfect square. And yes, they are perfect square because square root of x squared is x, which is also a whole number, and square root of y squared is y. So it meets the first condition for this expression to be a perfect square. 2 says the second or middle term is twice the product of the square roots of the other two terms, that is, the first and the last term. That is to say, if you multiply the first term and the last term together and find the square root, multiply it by 2, it must give you the middle term or the second term. And let's look at the example I gave you. That is to say, the product of the first term and the square root of the product of the first term and the last term must be twice the middle term. That is, what is the product of x squared and y squared? That gives us xy squared. That's x squared y squared, or you can call it xy y squared. Now, what is the square root of this? The square root of xy all squared is said to be xy, and the middle term must be twice of that. So if you look at it, this is 2x squared. That shows you that this particular expression meets the two conditions for it to be a perfect square, and that is why we said it is a perfect square. So we say quadratic expressions of the form x squared plus 2xy plus y squared, or x squared minus 2xy plus y squared, is said to be a perfect square. Okay, now let's take some examples. We are asked to factorize x squared minus 8x plus 16. This shows you that it is a perfect square because let's consider the two conditions, that the first term and the last term must be a perfect square. X squared is a perfect square. 16 plus 16 is a perfect square because square root of 16 is said to be what? 4. And the middle term is twice the product of these two, because x squared, if you multiply these two, it gives you 16x squared. So what's the square root of this? Square root of 16 is 4. Square root of x squared is x. So it says it must be twice that. So if you multiply this, this becomes 2 times 4 times x, which is equals to 8x. And that is what we have as the middle term. So that makes it a perfect square. So how do we factorize this? Using factorization method, we said since this is a 3-term expression which there is nothing in common, we have to make it a 4-term expression. Once it is made a 4-term expression, then you can factorize them in 2s. And how do we make them a 4-term expression that it does not change the sense of the expression? Now the rule says you look for 2 terms that when you add them together, it gives you the middle term, and when you multiply them together, it gives you the product of the first term and the last term. So how do we look for these 2 factors that we can use to replace the middle term? So multiply the first term and the last term together, that gives us 16x squared. So what we are going to do now is to look for 2 terms that when you multiply them together, it gives you 16x squared, and when you add them together, it gives you minus 8x. So how do you get them? Look for all the factors, all the 2 numbers that when you multiply them together, it gives you 16x squared, and that includes, you have 1 times 16 will give you 16. We have 2 times 8, it will give you 16. We have 4 times 4, it will give you 16. And what else? 16 times 1, which is also a same thing as 1 times 16. So what do we do in this case? If you multiply all of them together, it gives you 16. But when you add them together, will they give you minus 8? No, because this gives us 1 plus 16 is 17. Or even if you decide to change the sign, okay, let's give this one plus, minus, plus, okay, they'll give you positive, so let's put plus for all of them, and none will give you that. This is 10, this will give us 8, so none is giving us minus 8. But what if we decide to use negative in all of them? What happens? This becomes minus 17, this is minus 10, and this is minus 8. Now you discover that this happens to be that which will give us the middle term, because even if you multiply minus 4 times minus 4, it still gives you plus 16. So we are going to use these 2 terms and replace them with the middle term. So this becomes x squared minus 4x minus 4x plus 16. Now we have changed it from a 3-term expression to a 4-term expression without altering anything. So this now becomes, you can now factorize them in 2s. Look at these first two terms, what is common? Also look at the second two terms, what is common? Now, when you look at the first two terms, you discover that x is common. So we factorize out x into, when you divide the first term by x, what will be left? X will be left, so you put it in a bracket. That's how to factorize. Divide minus 4x by x, you have minus 4, and close the bracket. Now looking at the next two terms, what is common? You discover that 4 is common. I also want to inform you that once the first term is a negative, then negative is said to be common. So I'll take it that minus 4 is common. So factorize out minus 4 into, divide minus 4x by minus 4, you'll be left with x. Divide plus 16 by minus 4, you'll be left with minus 4. I have been able to factorize it from a 4-term expression to a 2-term expression. And which are the two terms? X into bracket x minus 4 and minus 4 into bracket x minus 4. So we are to then factorize it further into a 1-term expression. Now looking at these two terms, what is common? You agree with me that what is in the bracket is common. That is, x minus 4 is common, as we have it in this term and in the second term. So factorize it out again. This becomes bracket x minus 4 into bracket, when you divide here by x minus 4, you'll be left with x. Divide here by x minus 4, you'll be left with what? Minus 4. So we have been able to factorize it into a 1-term expression, and if you look at it, this can be said to be equal to x minus 4 squared. Now I have been able to factorize it as demanded. And if you look at it, remember we said an expression or a quadratic expression of the form x squared minus 2xy plus y squared can be factorized to be equal to x minus y all squared. And that is what we got. If you look at it, we have it as x squared minus 8x plus 16, and we got x minus 4 all squared as it's being factorized. So let's look at more examples. Example 2 says we should factorize 4a squared plus 12a plus 9. Now, looking at the two conditions to check if it is a perfect square, you agree with me that the first term is a perfect square as well as the second term, the last term, sorry, because the first term is what? 4a squared. 4 is a perfect square and a squared is a perfect square, as well as 9. And the middle term is twice the product of the first term and the last term. So we can also factorize it in that form. Or, okay, let's also factorize it using that form, and I'll give you another which can be used in factorizing it. So we have 4a squared plus 12a plus 9. Look for two terms that when you multiply them together, it gives you the product of the first term and the last term, and when you add them together, it gives you the middle term. And replace those two terms, replace the middle term using those two terms. So let's look for those two terms. When you multiply the first term and the last term together, it gives you 36a squared. And look for all two factors, and when you multiply them together, it gives you 36a squared. We have 3 times 6, 3 times 12, we have 1 times 36, 2 times 18, we also have 6 times 6, 4 times 9. They will all give you 36. But which of them, that when you add them together, gives you 12? Now, of all these sets, the one to choose must be the one that meets both conditions. So you discover that if you add up all of them, it is only 6 plus 6 that will equally give you 12. So we are going to pick this. No two can be the same. Okay, so 6a plus 6a will be that two term that satisfy that condition. So we are going to replace it with the middle term, giving us 4a squared plus 6a plus 6a plus 9. Remember, we said we cannot factorize it in a trinomial form because there is nothing that is common. But when you make it in a four-term expression, you can then factorize them in twos. So what is common in the first two terms? A is common as well as 2. So 2a is common. 2a into bracket, divide the first term by 2a, you'll be left with 2a. Divide the second term by 2a, you'll be left with what? Plus 3a. Sorry, plus 3. Do same to the next two terms. What is common? 3 is common. Just 3. Plus 3 is common. So we have plus 3 into bracket. When you divide 6a by plus 3, you'll be left with 2a. And when you divide plus 9 by plus 3, you'll be left with what? Plus 3. So factorize it further because it is now a two-term expression. What is common? You discover that what is in the bracket is common. Okay, so this becomes 2a plus 3. Then when you divide this term by 2a plus 3, we left with 2a. And when you divide here by 2a plus 3, we left with what? Plus 3. Of which this is equal to 2a plus 3 all squared. So this is how you can factorize that expression. Let's look at 3. Question 3 says we should factorize x squared plus 2xy plus y squared. Also, do same with what we have been doing. Look for, since this is a trinomial expression, we need to make it a four-term expression so that we can factorize it easily. So how do we get those two terms that can be replaced with the middle term? We said you look for two terms that when you multiply the first term and when you multiply them together, it gives you the product of the first term and the last term. And when you add them together, it gives you the middle term. So multiply the first term and the last term, you have x squared y squared. So look for those two terms that when you multiply them together, it gives you this. You have x and y. That's x times y will give you this. So those two terms are said to be xy and xy. Now when you multiply them together, it gives you x squared y squared. And we have x squared times y squared as well. But when you add them together, it will not give you, it will give you x squared plus y squared. But when you add this together, it gives you what? 2xy. So these two terms is the two that meet that condition, and you can pick them to replace the middle term. So with this, we now have x squared plus, instead of writing 2xy, we'll now write x squared xy plus xy, and then the last term, which is plus y squared. So factorize out the first two terms. This now becomes, what is common is x into bracket x plus y, and this, what is common, y is common, plus y into bracket x plus y. This is now a two-term expression, which when you factorize, it gives you x plus y into x plus y, which is equals to x plus y all squared, because they are the same in brackets. So this is what you will get. 4 says factorize x squared minus 2xy plus y squared. You have to do the same, and this becomes x squared y squared. Look for those two terms that when you multiply them together, it gives you x squared y squared. You have xy times xy, and we have x squared times x y squared. But when you add them together, will it give you minus 2xy? No. So if you make this negative negative, this happens to meet the two conditions. So we also replace it with the middle term, and this becomes x squared minus xy minus xy plus y squared. So factorize them out in twos. This becomes x into bracket x minus y, because x is common, and what is common here, minus y is common, into bracket x, divide minus plus y squared by minus y, you have minus y. Factorize them from a two-term expression to a one-term. This becomes bracket x minus y into x minus y, which is equals to x minus y all squared. Now, the aim of this course is to enable you factorize a perfect square expression into this without going through these steps. Okay, so remember what the rule says, that any expression, quadratic expression, that is in this form will give us this as its factor. So how do we get this from this? Now, having this at the back of your mind, you can use them in solving the first two examples I gave. Now, let's go back to the first two examples. The first example is this: x squared minus 8x plus 16. Now, if you can write it, now I'm going to solve this without factorizing it. I will give you the second method which is required of you in factorizing a quadratic expression. Now, this is what we are to factorize, but the rule says if it can be expressed in the form x squared minus 2xy plus y squared, that it can give you x minus y all squared. Okay, so let's see how we can express this in this form. So x squared minus 8x plus 16 can be simplified to be, this is already in square, which is x squared. This can be said to be minus, okay, let's make this a perfect square first, plus 4 squared, because 4 squared can also give you 16. 4 squared is also said to be 16. So I have made the first term and the second term, the first term and the last term, to be perfect squares. Now, what about the middle term? That the middle term must be twice the product of the first term and the last term. So this can be said to be x squared minus, factorize out 2. This becomes 2 into bracket 2x, 4x plus 4 squared. Now if you look at it, this is the first term and this is the last term, this is the middle term, which is twice the product of the first square root of the product of the first term and the last term. So all you need to do is, this now becomes, we said x minus y all squared. That is x minus, what is the value of y now? Y is 4 all squared, which is the same thing as what we got in the first example when I factorized it. So you can use it and factorize without going through all the methods we used in the first examples. That brings us to the end of today's class. In today's class, we have been able to treat the first objective, which says expressing quadratic equation as a perfect squares, and we have seen how we can factorize quadratic equations that are perfect squares. In our next class, we shall solve quadratic equation by method of completing the square. Before we go, I will leave you with this assignment. which we shall look at in the next class before we begin the class. That which of the following are perfect squares? Is it A, u squared minus 14u plus 49, or B, 6x squared plus 13x plus 6, or C, 2b squared plus 5b minus 7, D, u squared plus 2vu plus v squared? Now try to identify all those that are perfect squares and those that are not. In our next class, I shall give you the solution to these questions. Thank you for being attentive into this class. We advise that you like our videos, while you are also encouraged to subscribe. Also use the comment section to interact with us on how you feel concerning our lessons, and why you are also advised to share the link to your friends and families so that they can also be part of our class, for knowledge is wealth. Thank you and do have a nice day. See you in our next series.